Hello everyone, my name is Prithvika K, student of Sri Venkateshwara College of Engineering, Bengaluru, Department of Basic Science. My section is Devu. I'm currently pursuing my engineering degree under CSC EI stream, second sem. My USN is 1VE23CA036. Course title Introduction to Civil Engineering. Course code BESCK204A. And today's topic is about the program related to Centroid system. The given question is to find the centroid of the figure, and the step 1 says we have to check for the reference axis. If we don't find any such reference axis provided, we have to consider the leftmost part of the figure as y-axis and bottommost part of the figure as x-axis. Later, we have to check for the symmetry of the figure. If the figure is symmetric about vertical axis, then x bar is equals to the total width of the figure divided by 2. And if the figure is symmetric about horizontal axis, then y bar is equals to the total depth divided by 2. If the figure provided is not symmetric, we have to divide the figure into known geometrical components, and then we have to find the respective centroids of the components using the tabular column. Like, we just divided this figure into two triangles and two rectangles. Now let's calculate each of them with the use of tabular column. Like, the first component which I have taken is rectangle, and the area for this component is b into d, which is breadth into depth, 30 into 25, 750. Then I'm calculating centroidal distance from x-axis, which is y in millimeter, d by 2, which is depth by 2. 25 by 2 is 12.5. Centroidal distance from y-axis, which is x in millimeter, breadth by 2, which is 30 by 2, 15. Next, I'm calculating moment of area of x-axis, ay in millimeter cube. Like, for calculation of momentum, we'll just multiply area and the centroidal distance from x-axis, which is a into y, 750 into 12.5, which is 9375. And next I'm calculating moment of area of y-axis, ax in millimeter cube, which again I'll multiply area with the centroidal distance from y-axis, which is 750 into 15, which is 11250. Next, I'm calculating the next rectangle, which is situated a bit above x-axis and a bit far from y-axis, where I'm taking the area with same formula, which is b into d. 5 into 40 is 200. And next, I'm calculating centroidal distance from x-axis, which is y in millimeter. And in this part I'll be adding 25 extra because it's just situated 25 millimeter above the x-axis. So I'll be just dividing 40 by 2 and adding 25, which gives me 45. Next, the same way I'll calculate the centroidal distance from y-axis, which is x in millimeter. With same formula, I'll just add 25 because it's situated far from y-axis with the distance between is 25 millimeter. So I'll just divide 5 by 2 and add 25, which gives me 27.5. Then next I'll calculate moment of area of y-axis AY in millimeter cube, which is same the multiplication of area and centroidal distance from x-axis, where I get 200 into 45, which is 9000. Next, the moment of area of y-axis, ax millimeter cube, same the multiplication goes on between area and centroidal distance from y-axis, 200 into 27.5, which is 5500. Now calculating the triangle uh, component, where the area is half into base into height, where the base is 25 and the height is 35. So half into 25 into 35, we get 437.5. And for calculating centroidal distance from x-axis, I will just put the formula 1 by 3 into height, which is 25 divided by 3. I get 8.33. And for same, like I'll just multiply for the moment of area for x-axis, I'll just multiply area and centroidal distance from x-axis. So I get 3437.5 into 11.66. I just said wrong, right? And now I'm just calculating the last component, which is the next triangle, which is actually situated like 30 millimeter far from y-axis. Calculating the area with the same formula, which is half into base into height, I get half into 20 into 25, which is 250. And next I'm calculating the centroidal distance from x-axis, which is y in millimeter, where I'll apply the same formula as the previous one, which is 1 by 3 into height, which is 1 by 3 into 25. I get 8.33 as the answer. And next I'll calculate the centroidal distance from y-axis, like x in millimeter, where here I'll just add the 30 millimeter distance from y-axis as an addition, where first I'll just calculate 25, I mean 20 divided by 3 plus 30, which gives me 36.66. And next I'll just calculate moment of area of x-axis AY in millimeter cube, where I get the multiplication of 250 into 8.33 is 2082.5. And the same way I'll just calculate the moment of area about y-axis, which is ax in millimeter cube. I'll just multiply 250 into 36.66, which gives 9165 as the answer. Now let's just do the summation of area, where the summation of area is 1637.5, and the moment of area from x-axis is, which is AY, the summation of AY is 36,496.25, and the summation of AX, which is the moment of area about y-axis, is 29,559.375. After the summation of all three parts, we have to find x bar and y bar. For the formula for x bar is the summation of ax divided by the summation of a, which is 29,559.375 divided by 1637.5, where the answer is 18.051, and y bar is equals to 36,496.25 divided by 1637.5, where I get the answer is 22.287. These were the steps involved in the calculation part. and I have just put on this summary like how to calculate the centroidal system, where the first part involves finding the reference axis, then we have to find for the symmetry. Later we have, if there is no symmetrical part, we have to just divide the figure into known geometrical figure. Later we have to apply the formulas and apply the values within the table and calculate for the centroid or for the respective components, and later find the summation of ay, and ax, so that we can calculate x bar and y bar. Thank you for watching my video. I hope you people understood the concept and the steps involved in the calculation of centroid of a given figure or a system. Please do like this video, share and subscribe.